All right, what is up, you guys? Welcome to another episode on Prime Logic. Let's go for an interesting puzzle for today. If you want to solve this problem, please pause the video because I'm going to solve this problem right now. So our job is to find the shaded area. Obviously, we have a right triangle, so let's name it as ABC. So we have a right triangle and we have two intersecting lines inside this triangle such that all these little segments on the side of this big triangle are all equal, and they are equal to 5. So 5, 5, 5, 5. So what is the area of this shaded region? So let's start. So let's focus on this left little triangle here. Let's name this part. So ABCD. This one is D. So let's focus on triangle ABD, right? This is triangle ABD. And now let's also compare triangle BCE. So let me write it down here. Triangle ABD and triangle BCE. So these two triangles, they are right triangles, right? Because they share this angle here. They are right triangles. Their side, one of their side or legs is 5, another one 10, sorry. For example, in this triangle, it is 10, and the base here is 5. For triangle ABC, this side AB is 10, and the base, which is BD, is 5. So these two triangles are congruent, right? These are congruent triangle. It means they are just 100% the same. They have the same area and they are just tilted. So we can see the area of this triangle, both of them, equals 5 plus 5, which is one of the sides, 10, times base, which is 5, divided by 2. So 10 times 5, 50 divided by 2, 25. So each of those triangles, ABD and BCE, they have an area of 25. Okay, so far so good, nothing serious here. They are congruent triangles. So let me just draw a line from this vertex of big right triangle to this intersection point here. And let's name it as F, for example. Okay, so I just drew a line from this point to this intersection point. Now let's focus on this area, BEFD. Okay, so BEFD, this is an area here, and this area is shared among these two triangles. Okay, so just for now, just don't consider this line. So this area, which is BEFD. So this region is shared, is common in these two triangles that we talked about earlier. It is common among ABD and BCE, right? So since it is common, we can conclude that the shaded regions are equal as well. So we can say the shaded regions, let's just name them as X. So one more time, this region, BEFD, it is common between or among these two triangles, ABD and BC. So since this is common and the areas are also the same, 25, so we can conclude that this shaded area and this shaded area, they are 100% the same. They have the same area as well. So let's just name them as X. So another step towards the solution. Now let's focus on line BF, okay? So we drew a line here. Let's focus here on this triangle BFD, so triangle BFD and triangle BFD and triangle DFC. So what can you say? What can you argue about these two triangles in terms of the area? Obviously, they are not congruent because their shape is totally different, but we can say something about the areas, right? So, for example, let's focus on BFD. So the base is 5, right? And let's just, for example, draw the height or altitude here, okay? And then this altitude is also common and shared for the triangle DFC as well, right? This is the altitude. So since the altitudes are the same or shared or common between these triangles, the areas must also be the same. So we don't know the areas yet, but the area of BFD and DFC, these two triangles, they are the same. They have the same area. Okay, so since this area is X, we can also name this area as X as well. And then we can say the same thing exactly for these two triangles, for AEF and EFD, right? Because let me just rotate paper here. Yes. Okay. So you, for example, draw the altitude here as well. These two triangles, this one and this one, they have the same area, right? Because the heights are the same and the bases are 5 as well. So this is X. This also must be X. So now it's pretty much think over and it's clear now. We can just go with one of the triangles. So for example, on triangle ABD, the area was 25, right? And the area that consists of 3 parts that are exactly literally the same in terms of area. So X, X, X. So we can say 3X equals 25, right? X, 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 and this is the area of ABD, which was 25. In other words, X equals 25 over 3. So each of those segments, they have an area of 25 over 3. 25 over 3, and this, and this, and this. So since we want to calculate the area of the shaded region, and it is just 2 x's, right? It is comprised of 2 x's. So 2x, which is the answer for the problem, for the video for today. So 2x equals 2 times this fraction, 25 over 3, which is 50 over 3. And that's the final answer. And let's put a box around it. So the combination of these two little areas, shaded areas, is 50 over 3. So that was done. So that's going to wrap it up for today. That was done using plane geometry. So we didn't have to calculate a lot of things. That was just reasoning, analytical reasoning, plane geometry, etc. But I have a challenge for you. The bonus challenge is I want you to focus on this and I want you to solve this problem and this puzzle using analytic geometry. Okay, by analytic geometry, I mean just I'll find the coordinates, for example, of these points, and then because we have the values, the length here, 5, 5, 5, 5, then you can, for example, write down the equation for the line AD and maybe the equation for the line CE as well. That's a little longer, yes, for sure, but it's worth trying. And then you can, for example, find the coordinates of the intersection point F, and then somehow find and calculate the areas of each of those triangles. And I think that's interesting. I want you to focus on this and solve it using this way and put it in the comments below, or maybe if you can solve it in any other way. So that's going to wrap it up for today, guys. I hope you enjoyed this video. If you found this video useful, please like the video and subscribe to the channel, and see you on our next video on prime logic.